Ever get that feeling like your brain's just running out of RAM, like you're trying to hold on to too many thoughts and they just slip away?
Absolutely. That feeling of hitting a mental wall, it's a very real limit.
Right. And today we're diving deep into some really foundational research that tried to actually put a number on those limits. We're talking about how much information we can truly process at once.
We are indeed. Our main source is a classic paper, really influential, from 1956 by George A. Miller. It's called The Magical Number 7, plus or minus 2, Some Limits on Our Capacity for Processing Information.
1956. Wow.
Yeah, although it's worth noting he actually first presented the ideas in 1955. Our mission today is to unpack Miller's work on, well, the surprisingly tight constraints on our ability to make what he called absolute judgments.
Okay, so Miller kicked this off because he noticed something. Kind of strange, didn't he? This number 7 kept popping up everywhere in his research.
Exactly. He described it as feeling persecuted by an integer. It wasn't just random. 7, or numbers very close to it, kept emerging from different experiments looking at our basic perceptual abilities.
So he looked into these absolute judgment studies. What does that mean exactly?
So basically, these experiments measured how accurately people could assign labels or numbers to different stimuli presented one at a time. Think identifying musical pitches or judging how loud a sound is.
Okay.
And around the same time, information theory was becoming big. So people started framing these experiments differently, seeing them as measuring our capacity to transmit information. How much of the information present in the stimulus actually gets through our perception and into our response.
Information theory sounds complex. Is there an easy way to grasp it?
Well, think of it like reducing uncertainty. The more possibilities there are, the more information you need to pinpoint the right one. Information theory gives us a mathematical way, using bits, to measure that reduction.
Right, like narrowing things down.
Exactly. So in these experiments, the transmitted information tells us how much the participant's response reduces the uncertainty about which stimulus was actually presented. It's a bit like correlation, quantifying the relationship between input and output.
Gotcha. So how did this play out in practice? Where did the 7 come from?
Let's look at some specific studies Miller reviewed. Pollack, back in 1952 and 53, studied absolute judgment of pitch. He played listeners different tones and had them assign numbers to identify them.
Okay.
What he found was pretty striking. With just 2 or 3 tones, people were perfect. But add more, say 5 or 6, and mistakes crept in. The amount of information transmitted plateaued at around 2.5 bits.
2.5 bits. What does that translate to in terms of like distinguishable notes?
That 2.5 bits corresponds to being able to reliably distinguish about 6 different pitches. 6. Even if the range of frequencies was huge.
Only 6. That seems low, especially compared to musicians.
Well, yes. Miller acknowledges exceptions like people with absolute pitch who can identify many more.
Yeah.
But for the average person, the limit was around 6 or 7 distinct categories. Sort of makes you wonder about those 7-point reading skills psychologists love, doesn't it?
Huh, it really does. Was it just pitch, or did other senses show similar limits?
Very similar. Garner, in 53, looked at loudness. Carefully spaced tones, different intensities. He found a channel capacity of about 2.3 bits.
Which is
But
about...
at 5 distinct loudness levels. Again, in that same ballpark.
Okay, pitch and loudness. What else?
Then there was taste. Beebe Center, Rogers, and O'Connell in 55 used different concentrations of salt solutions. Their result, even lower, about 1.9 bits.
Wow. So only like...
Roughly 4 distinguishable levels of saltiness. Taste seems a bit coarser, you could say, in this absolute judgment task.
But I thought vision was maybe a bit better. Judging position or something?
You're right. Haken Garner in 51 had people judge the position of a pointer between 2 markers. That showed a higher capacity, around 3.25 bits.
And that means...
Between 10 and 15 distinct positions. That was actually the highest capacity found for any single unidimensional stimulus variable. Later studies on things like size, hue, brightness, even touch intensity or location, all tended to hover around that 2 to 3 bit range.
So putting it all together for these single dimensions.
The capacities were remarkably consistent, despite the huge variety in senses and stimuli. The average was around 2.6 bits, standard deviation just 0.6 bits. Yeah. That means people could typically distinguish somewhere between, say, 4 and 10 categories. That's the 7 plus or minus 2 range Miller was talking about.
Okay, but hang on. This feels really limiting. I mean, we recognize thousands of words, hundreds of faces. How does that square with only being able to handle, like, 7 categories?
That's the crucial distinction Miller makes. All the studies we just mentioned were unidimensional. They varied stimuli along only one dimension, like pitch or loudness or position.
But real-world things aren't usually like that.
Exactly. Real-world objects and events are multidimensional. A face varies in shape, features, expression, color, tons of dimensions. And when you add dimensions, our capacity increases.
Okay, so how does that work? Does it just add up?
Not quite additively, but it definitely increases. Clemmer and Frick, for instance, had people judge the position of a dot in a square that's two dimensions, right? Horizontal and vertical.
Right.
The information transmitted jumped to 4.6 bits. That's about 24 distinct positions they could identify. Much better than the 1015 for just one dimension on a line.
So adding a dimension helped a lot, though maybe not quite doubled the capacity in bits.
Precisely. And other studies show the same trend. Combining saltiness and sweetness judgments, or loudness and pitch, or hue and saturation in colors, all increase the total information transmitted compared to judging just one dimension alone.
And presumably, the more dimensions.
The higher the capacity. Pollock and Fix did a really interesting study in 1954 using sounds that varied along 6 different auditory dimensions, things like frequency, intensity, rate of interruption, duration.
6 dimensions.
Each dimension had 5 possible values, and they found listeners could transmit 7.2 bits. That's about 150 different sound patterns they could reliably identify. Now, that starts sounding more like our everyday experience, doesn't it?
Yeah, 150 categories feels a lot more realistic than just 6 or 7.
So the takeaway here is that we seem to make rather crude judgments along any single dimension, but we can make many of these crude judgments simultaneously across different dimensions. Miller even speculated this might be an evolutionary advantage.
Making lots of rough judgments at once. Makes sense.
It also connects to how language works, like distinguishing speech sounds, phonemes, based on combinations of features like voicing, place of articulation, and so on.
Okay, so that handles the absolute judgment part. But Miller's title also mentions memory, right? The span of immediate memory. Is that the same
No.
limit?
That's the other key part of the paper, and initially, Miller himself wondered if maybe our memory span was also limited by a fixed amount of information, around that 2.5 bits or so.
But it turned out not to be the case.
Nope. He discussed experiments, particularly by Hayes in 1952, that tested memory span for different kinds of items. Binary digits, which have 1 bit of info each, decimal digits, about 3.3 bits, letters, about 4.7 bits, even short words.
And what did Hayes find?
He found that the memory span, the number of items people could recall immediately, was relatively constant at around 7 items, regardless of how much information each item contained in bits. Pollock replicated this more elaborately, too.
So wait, for absolute judgment, the limit is the amount of information, about 2.5 bits or roughly 7 categories for one dimension. But for immediate memory, the limit is the number of items, also roughly 7.
Exactly. That's the crucial distinction. Absolute judgment is information limited. Immediate memory is item limited. Miller called these items chunks. Our short-term memory buffer seems to hold about 7 chunks.
Chunks, okay. But surely we can remember more complex things than just 7 random digits.
We can, and the way we do it, according to Miller, is through recoding. We group information into larger, richer chunks.
Recoding, like organizing things.
Precisely. Think about learning Morse code. At first, you hear individual gits and das, tiny chunks. Then you learn to group them into letters, bigger chunks. Then letters into words, words into phrases, progressively larger, more meaningful chunks.
Ah, I see. So each chunk can hold more information.
Exactly. By recoding, you increase the number of bits per chunk, effectively packing more information into those roughly 7 available memory slots. Smith did experiments showing this directly by having people learn to recode sequences of binary digits into groups representing octal digits, for example.
Did it work perfectly? Could they remember 8 times as many binary digits if they recoded into octal chunks?
Not always perfectly, especially at first. It suggests that the recoding process itself takes effort and needs to become almost automatic to be truly effective. But with practice, people got much closer to the theoretical limit based on their chunk capacity.
So recoding isn't just a party trick. It's fundamental to how we handle complex information.
Absolutely. Miller argued it's perhaps the most important process we have for overcoming our cognitive limits. Think about summarizing something in your own words. That's a powerful form of verbal recoding. We chunk complex ideas into familiar concepts.
That makes a lot of sense. It connects to how we learn and remember everything, really.
It does. Using imagery, finding patterns, clustering related items, these are all likely related to this fundamental process of creating meaningful chunks.
Okay, so let's try and summarize the big picture from Miller's paper. We've got these 2 main bottlenecks.
Right. First, the span of absolute judgment. For stimuli varying along a single dimension, we can only reliably distinguish about 7 categories, plus or minus 2. That limit seems tied to the amount of information, around 2.5 bits.
But we get around that by...
By judging things based on relative differences rather than absolute values, and crucially, by perceiving things across multiple dimensions simultaneously. Adding dimensions increases our overall information capacity significantly.
Okay, and the second bottleneck.
The span of immediate memory. We can only hold about 7 items or chunks in our active consciousness at any one time. This limit is based on the number of chunks, not the information per chunk.
And the way around that limit is?
Recoding. Organizing information into larger, more meaningful chunks, increasing the amount of information packed into each of those 7 slots. This is key to learning, language, and probably most complex thought.
So Miller's paper, even back in the 50s, gave us this incredibly powerful framework using information theory to understand these fundamental limits, but also the clever strategies we use to push past them.
Exactly. And that magical number 7. Miller himself concluded it might just be a coincidence that both limits hover around that number. The underlying mechanisms are quite different.
A fascinating coincidence, though. It really makes you think about how much of our intelligence relies not just on raw capacity, but on these smart ways of structuring and repackaging information, doesn't it?
It really does. How much of what we think of as complex reasoning is actually just very efficient chunking and recoding happening beneath the surface? It's quite a thought to leave with.